In this video, I will go over the USB stabilizer product line. I'm going to explain the differences between the 5 different editions of this product that exist, and I'm also going to cover RStudio Technician software. So this video is meant to be like a training video for people who already have this product, so that everybody can take advantage of the functionality that these products offer. So it's a bit like a video user manual where I'll explain the most important things. It's probably going to be pretty long. There's a lot that I need to cover. So let's get started. So first, a couple of major announcements. So one is we're about to release a new product. So it's this device right here. So it's a high-end version of the USB stabilizer. This is a 10 gigabit device instead of 5 gigabits, so it's a lot faster. It's also a lot faster for error handling. We figured out some better ways to reset the drive to process bad sectors faster. It also works with 3 drives at the same time instead of 1 drive, and it has ports for SATA, M2 NVMe, and USB instead of just USB. So overall, this is a much more high-end device. It's also quite a bit more expensive. The price is going to be about $2,500 US. I will make a separate section of this video specifically on this new device. It'll be near the end. I'll put a link down in the video description below because I know a lot of people are waiting for this device to come out, and you can go straight to that if you're interested. Another I guess related announcement is that we're dropping the price of the current USB Stabilizer Pro by $400. So the price is going down from $1,390 down to $990. So about from $1,400 to $1,000. So this is just because there was a premium on the USB Stabilizer Pro because it was the best USB read and stability handling tool in the world, and now it's no longer the best. The new device is the best, so the old device has decreased in price because the premium is gone. The old device is not going anywhere, so it's our main product, and it's probably going to remain our main product just because of the price point is quite low on it. So we're still going to be developing it, still going to be updating it, selling it indefinitely. So this new device is just a high-end edition for everybody who's doing data recovery professionally. Now on to the current stabilizer device. So there are 5 editions of this product. There's Guardonix Standard, Guardonix Professional, USB Stabilizer Tech, RapidSpar USB Add-on, and USB Stabilizer Pro. So USB Stabilizer Pro is the full version of this product, and all of the other editions are less expensive and less capable. So first I'll talk about what is the same across all editions. So the same is the hardware. So all 5 are exactly the same hardware device, and basically what we do is we limit features or remove features on the firmware level. Unfortunately, far too many people kind of make the assumption that because the hardware is the same, the product is the same. This is really not the case. It's a bit like having 2 cars and one car is locked into first gear. It can't change gears. So for some purposes, it'll be the same, and for other purposes, it'll be dramatically different. And hopefully this video will make the differences very clear. Because the hardware is the same, it is possible to upgrade from one edition to another one by paying the exact price difference between the 2. And it's just an online firmware upgrade, so nothing needs to be shipped. We just flip a switch and your unit becomes a more advanced edition. It's very simple to upgrade. We also give a free 1-month demo to all owners of the low-level editions, so that you can try out the full version, which is the USB Stabilizer Pro. So you just have to ask for it. Everybody gets 1 month, and we'll give it to you. So during the demo period, it does require internet, but otherwise it's a fully functioning USB Stabilizer Pro unit. But generally, if you buy the product, and all of these products, they don't require internet. There is no charge for updates. There is no recurring costs whatsoever. It's a piece of hardware. You buy it once and you own it and you do whatever you want with it. The warranty is 1 year. After the warranty expires, we do provide warranty replacements for a fee. So basically, for example, if it fails after, I don't know, 3 years, if you have the lower level versions, which are Guardonix Standard, USB Stabilizer Tech, or RapidSpar USB Add-on, then the replacement cost is only $200 US. So what we do is we'll ask you to take a picture of the old unit circuit board being destroyed, and then we'll sell you a new circuit board for $200 plus shipping. The replacement cost for Guardonix Professional is $280, and the replacement cost of USB Stabilizer Pro is $360. So they're all very roughly 1/3 of the price of a new one. So you don't have, if it fails, you don't have to buy it again. You can get the replacement for cheap. So this cheap replacement offer is available to everybody who bought units from us, new units from us, or in other words, it's not available to anyone who bought their unit secondhand from somebody else. So of course, people sell their units sometimes on eBay or forums or anywhere else, and if the unit was bought secondhand, then we do not replace those for cheap. So this is the only limitation for secondhand units. If you're buying one secondhand, so the only thing we ask is that the registered owner sends us an email to let us know that they sold their device to somebody else, so that we register it in our system. And this way we transfer any remaining warranty, and of course we honor the warranty no matter what. And we provide support to the new owner if it's properly registered with us. Just some general advice for when you're buying used units. It's quite important so before you buy the unit, get the serial number from the seller and get their name or company name, and then send us an email to make sure that this person is actually the owner of this device. Because what happens a lot is that these units get stolen. So sometimes a technician might be working at some company, and then they leave the company and they walk out with the stabilizer in their pocket or another piece of hardware. So this happens a lot in the data recovery industry. Like I've dealt with this many more times than I could ever remember. And then of course this person is not the proper owner, and what's going to happen is that so you buy this stolen unit, and then, for example, you contact us for support, and if we see that the serial number belongs to somebody else and it hasn't been registered with us, what we're going to do is we're going to send the registered owner an email and ask them what's going on, if they sold this unit, or if they didn't sell this unit and it was stolen from them. And then if they find out it was stolen, a whole mess begins usually. Many times they go to court against the person who then sold this unit and stole it from them. And then you're going to get involved into all of this. It's definitely not something that you want. It's a nightmare. Now back to what's the same across all product editions. So because the hardware is the same, of course they all have the same short circuit protection for both the power lines and the data lines of the USB port, source port. They also have the same overvoltage protection. So if you accidentally connect like a wrong power supply, like from a laptop or some adapter that's higher voltage than it's supposed to be, the device will not break. We have protection for that. And all of the functionality that has to do with essentially making sure Windows doesn't have problems is the same. So what are the sources of freezing when you're dealing with a degraded drive? Freezing or errors or problems in general. So the sources are, number one, the drive itself. Number two, the storage controller, USB controller in this case, and its firmware, which is inside of the PC. Next, you have the system software, so the BIOS of the computer. And then you have the operating system, Windows, and you have the software application itself that's accessing the drive. So all of these steps can cause issues. So of course, the USB stabilizer has a large number of features that basically hide problems from the computer. So as you've probably seen in the demo video, we fake the whole connection. We filter everything out that Windows or the computer doesn't like. So all of that is the same across all product editions. So they all have the same write blocking as well. So the way the primary way we differentiate different editions is that we limit the control over read timeout. So read timeout is how we help manage the device itself. So if the drive freezes, what we do is we basically wait a certain period of time, which is the read timeout window, and then we take steps to make the drive abort whatever it's doing. So for hard drives, this is a hardware reset, and for flash devices, this is the repower. So how long we wait, the read timeout window, is the primary difference between the different editions. So of course, USB Stabilizer Pro, it's customizable, so you can choose whatever you want. And all of the other editions have limits on how quickly the device will do this. So for USB Stabilizer Tech, it's 2000 milliseconds, so 2 seconds. It's a very, very long read timeout. For Guardonix Professional or RapidSpar USB Add-on, when it's used with RapidSpar Assistant, the limit is 1250 milliseconds, so 1.25 seconds. And Guardonix Standard has no read timeout at all, so it doesn't do resets really. This is an enormous difference between the product editions, because typically you would want the read timeout to be a few hundred milliseconds, so maybe 300 or 500 milliseconds. Of course, it depends on the drive. So these longer read timeout windows that the less expensive editions use. So what that means is that the drive will be doing more internal read retries before we abort them. So it's going to be, number one, wasting time. So you won't be able to do drives beyond a certain number of bad sectors. And number two, it's taking more damage because of course these read retries are harming itself. So if it's a hard drive, it's more platter damage. If it's a flash device, it's more flash memory damage. And so the drive will fail at an earlier point if a longer read timeout is used. Of course, all of these versions are much better than nothing because Windows itself has a 20-second read timeout. And it will only execute it a few times before it will drop your drive and just completely refuse to work with it. So even like the most basic versions, USB Stabilizer Tech, that's a lot better than nothing, but it's also a lot worse than USB Stabilizer Pro. So there will be a clear difference in how much data you can retrieve before the drive fails completely. Next, I'll talk about adapters. So the USB interface is very flexible in the sense that you can connect practically any storage device to it through an adapter. So in terms of adapter support, so pretty much any adapter will work. The only limitation is that the adapter must have only one channel. So basically it must be one source drive to one USB port. Or in other words, what's not going to work are those adapters that are like multi-card readers that convert CF card, SD card, and like 7 different cards to a single USB port. Those will not work with USB Stabilizer. So it needs to be one-to-one. Now, being compatible and working well are two different things because of course, if the connection is going through an adapter, the adapter will make a difference on the read and stability handling. Now for flash devices, this doesn't really matter so much because the process is to repower them when they get hung up. So adapter can't really stop itself from being repowered, so pretty much all of them work the same way. Now for hard drives, it's a totally different situation. So for hard drives, we're using resets instead of repowers. And the adapter has to be able to pass the reset in order for read and stability handling to work properly through it. So for hard drives, there are 3 different types of hard drives. So one is native USB hard drive, where of course you're not using any adapters, so you don't have to worry about this. Next, you can have a SATA or SAS hard drive. So for SAS hard drives, there is one type of chipset that converts SAS to USB on the market, and you will find some adapters for that chipset. However, this chipset cannot handle any read and stability issues. So basically, that chipset, we tested it, and it's only going to work for totally healthy drives. So more or less, you can't really do degraded SAS drives with USB stabilizer. So it'll only work with totally healthy SAS drives. So for SAS, unfortunately, you have to buy native SAS tools, which are, several $1,000s. And then we have SATA drives. So SATA drives, there are many adapters that convert SATA to USB. So the only adapters that work well are those based on any of the chipsets made by AS Media, like ASM 1153, ASM 1051. It doesn't really matter which chipset, but it has to be made by AS Media, because other chipsets, they tend to just freeze forever on bad sectors, or when they get sent a reset, they just freeze, and then it just can't work whenever there is a drive with any issues. So you have to make sure you're using any of the adapters made based on an AS Media chipset. Now, of course, we include the right adapter if you buy our adapter set, and we also include such an adapter for free with every USB stabilizer tech unit. So we've included one since the very beginning, and we're going to continue including one. So if you buy that bundle with our studio, you're going to get a SATA to USB adapter from us. That's based on an AS Media chipset, so you don't really have to worry about this. Otherwise, like for example, if you buy USB Stabilizer Pro by itself and you want to use it with SATA drives, you have to find the right adapter, or you're going to have a very, very bad time. One interface that I wanted to give special attention to is the M.2 interface. So a lot of people are very, very confused about this interface, and they lose cases over it. So I wanted to try to help clear up any confusions. So the number one, source of this confusion is the lack of understanding that interface and protocol are 2 completely different things. So the interface communicates the physical properties of some particular port. So like the number of pins, which pins go where, maybe which level of voltage signifies high signal or low signal, things like that. While protocol is the language that is used by the storage device to communicate over this interface. So you could have an interface and a range of different protocols that can be used to communicate over this interface. So for common interfaces like SATA, they all use HCI protocol. So there's one interface, one protocol. So a lot of people kind of came to the assumption that they're the same thing. Interface and protocol are the same thing. So if you see one interface, you can assume that it's going to be some particular protocol. So with the M.2 interface, this is not right. So you have 3 different physical types of M.2 interfaces, and you have 3 different protocols that these interfaces could be using. So any one of these interfaces could be using any one of these protocols, and you have to figure out what protocol your SSD is using, because you have to connect it using the right adapter, because the adapter will only support one or two of these protocols, and it will not work with all three of them. And if you connect the wrong protocol SSD to the adapter, then it's not going to work. It's not going to identify the SSD. It's going to act just like it's dead, but it's just because you connected the wrong adapter. So in terms of the physical interfaces, there is B key, B plus M key, and M key. So there's a tendency that B key, M2 SSDs, they tend to be HCI protocol, but they don't have to be. They could also be PCI Express HCI or PCI Express NVMe. So same thing with B plus M key. Generally, they're most commonly HCI, but they could be either of the two protocols either. And M key SSDs, they tend to be one of the PCI Express protocols, whether it's NVMe or PCI Express HCI, but it's possible for them to be SATA as well. For example, when you see those adapters that convert M.2 to SATA, those will only work if the protocol of your SSD is HCI. So if the protocol is PCI Express HCI or PCI Express NVMe, it's not going to work. In the adapter set that we supply, we use an adapter based on the JMS586 chipset. And the good thing about that chipset is that it supports both PCI Express HCI and PCI Express NVMe protocols. So you don't have to worry about separating those two from one another. So the only thing that you have to think about is whether this M2 SSD is SATA or HCI protocol, or if it's one of the two PCI Express protocols. So typically you can do this by Googling. So I find the easiest way to figure this out is just to find the maximum rated speed of this SSD. So if the speed is below 600 megabytes per second, then it's probably using HCI protocol. And if it's above that, then it's probably using one of the PCI Express protocols. So if it's the HCI, then you have to buy one of those passive adapters that convert it to regular SATA. And then you have to connect it through your SATA to USB adapter. So you're using two adapters connected into each other to connect such an SSD to USB stabilizer. If it's one of the PCI Express variants, then you connect it to the M2 to USB adapter that we supply. Now on to system requirements. So you need a computer running Windows 10 or Windows 11 64-bit. We do not support any other operating system, so you can't run it in Windows 7 or Linux or Mac OS or anything like that. We're never going to support any other operating systems because supporting other operating systems means we have to do the development all over again. Because the product is essentially us figuring out how Windows works and what causes it to have issues when dealing with degraded drives, and then we find ways to get around those issues, typically by tricking Windows into believing that something else is happening. So every operating system has a different design and it will have completely different problems. So for us to support another operating system, we have to do this development all over again, and it's definitely not going to be worthwhile for us. There's just too few people using other operating systems for us to ever go through all of that development again. If you're a Mac shop, if you have no PCs whatsoever, generally we can run Windows by boot camp and it'll work fine, or at least many people tell me that it works fine that way. However, we ourselves, we don't have any Macs, we don't use Macs, so it's hard for me to say for sure. I just know a lot of people use it like that. If you run like VMware, like Parallels, that's almost certainly going to give you problems. But Boot Camp should be okay. Between Windows 10 and Windows 11, if you have a choice, use Windows 10. Right now, there is no real difference between Windows 10 and Windows 11. However, Windows 11 is still being updated in major ways. So meaning Microsoft may release a major update that changes the storage architecture, and that can cause all kinds of issues. So over the last few years, they only did that once. They did that in the fall of last year. There were many changes to the storage architecture, and basically it completely broke our USB stabilizer, and we had to drop everything. And it took us 6 or 7 weeks to release an update that got it working with the new Windows 11. And we have no way of knowing whether that's going to happen or not in the future. Probably it will happen at some point, and it will break again, and we'll have to do another update. We have no control over it, so it's very hard for me to say. But that's why Windows 10 is better, because they haven't updated Windows 10 in significant ways for more than 5 years now, and almost certainly they never will update it significantly again. So probably it's just going to keep working in Windows 10 forever, and Windows 11 we will have to do some updates as Windows updates. In terms of hardware requirements, the only part that really matters for a USB stabilizer is the USB 3 controller in your computer. So basically it'll work with any USB 3 controller that works according to USB 3 specification. So the unfortunate reality is that some USB 3 controllers do not work according to USB 3 specification, or at least they only implement some commonly used parts of USB 3 specification, which is what's necessary for home users to connect devices like mice, keyboards, USB sticks, whatever. We use the USB 3 specification much more fully to do some of the tricks and problem hiding that we're using in USB 3 stabilizer. And if the USB 3 controller doesn't have proper support, then it may cause problems. So realistically, what that means is that if you have a computer built from parts made in the last 5 or 6 years, you're almost certainly going to be fine, because for more than 5 years now, pretty much all USB 3 controllers have been good. They all fully abide by USB 3 specification, and there are no problems. Now, older computers, like 2017 and older, that can be hit or miss. So some of them are really only made for very basic use, and kind of the symptoms can be very, very different depending on the USB 3 controller. It can be very hard to say. So if it's a computer from 2017 and older, you may have problems with it, using it with the USB stabilizer. So you really can't really know until you try it. If it's a desktop, then you can buy like a PCI Express USB 3 controller. So anything that's made by AS Media works well, like ASM 1142 or ASM 3142. Those are good chipsets. You won't really have problems with those. But again, you might be fine with what you have. Even if it's an older computer, there's no way to know. You really have to try it. Generally, what you'll see is like freezing, crashing, kind of, it could be a wide range of issues, but usually it's obvious that something is wrong. Now, branded computers, they tend to be worse than computers built from parts. I'm talking about laptops and any computer where you're buying like the whole desktop tower under a certain brand pre-built for you. So there are two reasons why those computers are worse. Number one is that they tend to use older hardware. So if you're buying a computer, I don't know, from 2019, the hardware, the USB 3 controller that it's using, quite possibly is a few years older than that. Could be from 2017 or even older. And of course, older is worse, especially when it comes to the USB 3 controller. And the second reason why they're worse is that sometimes they have modified Windows on them. So what we're doing with the USB stabilizer is essentially we're modifying Windows. And if our modification clashes with the modifications made by the system builder, there could be problems, severe problems because of that. But even with all of that said, newer computers, like if it's made in 2020 or newer, it's almost certainly going to be fine, even if it's like a branded computer. This is mostly an issue with older computers. Worst case scenario, like we have seen a couple of branded computers that have like a severely modified Windows, particularly in regards to their storage architecture. And the only way to get those working occasionally is to reinstall Windows, reinstall like a standard unmodified version of Windows 10 or 11. Potentially that could be necessary to get it working well with USB stabilizer if it's a branded computer. But the chances are low, like most of them. If they're made in the last few years, it's probably okay as it is. Now I'm going to move on to the more practical section of this video. The last thing I wanted to say is that please feel free to contact us if you have any problems. You have unlimited support, and getting feedback from customers is how we figure out what we're going to develop next. Because when it comes to read and stability issues, every drive is unique, and every year there are different new types of read instabilities coming out on the market, like different behaviors of devices. And feedback from customers through support is how we figure out that this is happening. And this is how we decide to add new features to the product. This is how we find out that people have problems. These days, very, very few people call or ask for support by email. It's very unfortunate. People just tend to suffer in silence, which is bad for everybody. I do most of the support myself, so you're probably going to be dealing with me. We have a very good tracing engine, so if something doesn't work, you can start a trace, and we'll be able to tell quite a bit based on that trace. And it can be quite difficult to figure out problems on your own if something is going wrong. So please feel free to contact us if you have problems. So first I'm going to go over installation. So the installation itself is very straightforward. You just download the relevant software and you press the install button. Then you reboot your computer. So there's really nothing to it. I'm not going to show it. But there are a couple of steps around installation that are less obvious that I am going to show. So before installation, the one step that we require you to do is to turn on system restore. So we just type in here. So this has to be on. So if it's off, you configure and you press turn on and you hit apply. So the reason this is required is because our driver is a kernel driver. So if something happens during installation, your computer may fail to boot. Realistically, this only happened once or twice over the 5 years that this product has been around. But because it's theoretically possible, we require everybody to turn on system restore, because this will completely protect you. So even if something very strange happens, you can just roll back and nothing bad will happen. So this is something that we require you to do before our driver will install. Otherwise, it will give you an error and it will refuse to install. So after installation, so let's say we've installed our driver and we have rebooted. The first step that should be done is turning off the sound notifications that Windows makes when you connect or disconnect a device. So we go to Start menu, type sounds, change system sounds, and it's these ones right here. So the reason we have to do this is because when we're going to be processing bad sectors, we're going to be resetting or repowering the drive, and the filtered connection to the source drive will be appearing and disappearing as this happens. And whenever this happens, Windows is going to make those sounds that it makes every time you connect or disconnect a device, and it's going to be extremely annoying. It's just going to be constantly making that noise whenever it goes through bad sectors, and it's much easier to just disable the sound so that this doesn't happen. The second thing we're going to do after installation is we're going to check if some sort of third-party driver is loading itself to the stabilizer hardware. So we're going to again go into the Start menu, we're going to go to Device Manager, and the stabilizer drive appears as if it's a drive, because it's basically an ARM processor that pretends to be a drive. We have to pretend to be the drive. That's kind of the main point of the device, is that it emulates the connected drive. And because we're pretending to be the drive, some sort of third-party software that works based on drivers may load itself on our device. So by far the number one culprit is software called MacDrive. It's by Paragon, and so what they do is they allow you to mount Mac formatted drives in Windows Explorer. So they completely break us because they start loading their driver to our hardware, and it just destroys our system completely, and then nothing will work. So basically, you're going to look on the screen, and you should see nothing more than these 4 drivers. This is all you should see. If you see some other driver there, some 5th or 6th driver there, you have to uninstall those drivers, which is done by essentially uninstalling whatever software is using those drivers. Unfortunately, there's no other way. We have to present ourselves as a regular storage device to provide the functionality that we provide, and other drivers may load themselves on us, and that just breaks everything. I've contacted Paragon Software because they can easily stop their drivers from loading, because we have a unique vendor ID on our hardware, so they can very easily stop themselves from loading, and therefore their products could be used at the same time as our stabilizer. But they haven't responded to me when I asked them to do this. So basically, if you're using that software, it cannot be used at the same time as the USB stabilizer, unfortunately. Now I'm going to go over the RStudio Technician and USB Stabilizer Tech bundle. So I've already installed our driver, and I restarted the computer. So here is the first thing that we see. So I'll briefly cover what these settings do. So the setting that's very, very important is this one. So this defines what the device will do when the read timeout window is reached. So basically, it's going to wait the 2000 milliseconds after sending a read command. If the drive doesn't respond with the data within those 2 seconds, then it's going to do either a reset if a hard drive is selected here, or it's going to do a repower if SSD is selected here. So basically, you have to be very careful about selecting the right setting here, because it'll just be a mess if this is wrong. So if you have a spinning drive, you have to select HDD. If you have any type of flash storage device, you have to select SSD. Unfortunately, we can't select this automatically. Like, there's no command in USB protocol that lets us know whether this is a flash storage device or a hard drive. So you have to select this yourself. Speed optimization. So this only matters for healthy and quick flash storage devices. So like when you're reading healthy areas from an SSD, this will boost the speed from about 320 to about 400 megabytes per second. That's all that it does. It doesn't do anything else. So it's only to make already fast flash storage devices even faster. It does not do anything for like bad sector processing speed or anything like that. Just leave this on and don't worry about it. USB speed, pretty much in all cases you can leave this on auto. Very, very uncommonly, some devices, especially flash devices, will read better on USB 2. So you could force it to USB 2 and hit apply. But it's quite uncommon. Usually just leave it on auto and don't worry about it. Turn off drive if inactive. So this will automatically turn off power if the drive is inactive for, I believe it's 5 minutes. So generally, even 5 minutes is quite a long time. You should be mindful of the fact that storage devices will start doing bad things to themselves if they're allowed to idle. So for hard drives, it's about 20 seconds. So if you let a hard drive idle for 20 seconds, it will start doing a self-scan. So it will start basically reading its own surface and looking for bad sectors to reallocate, which is bad news because it's going to be basically degrading as if it was being read, but you're not actually going to be getting any data out of it. So just be mindful of that fact and be ready to start the recovery when you power on the drive. For solid state drives, it's even worse. Like they will start doing things within seconds of being powered on. So it's even more important to just power on the drive and then start reading as soon as possible. So it's just be mindful of that. So we connect the drive and we power on the drive. So the first thing we're going to see is drive identification. So we have it right here. So pretty much all USB drives are SATA drives behind an adapter. So in this case, I'm actually using a SATA drive connected through an adapter, but even native USB drives are pretty much the same thing. So ATA model and ATA serial number. So these are the actual model and serial number of the drive. So the stabilizer is getting them by using ATA over USB commands. So we're basically sending SATA commands and we're encapsulating them by USB. And so this is the actual real disk ID of the drive behind the adapter. So we show it right here. So generally, when you're just first working on a drive, you want to make sure that this is correct, because if a drive is mechanically damaged, sometimes it will identify but incorrectly. So you might have the wrong capacity there, you might have the wrong model, or something like that. So the first step I take is I take a look at this and I make sure that this is correct, because if it's wrong, then probably my drive is just dead completely, and some kind of repair will be necessary to move forward. So now that I've checked that this is correct, next step is I'm going to look at this partition list. So I'm not going to show a case where the right partition shows up and then you just double click on it and you save files. That's a very simple case. Anybody can figure that out. And I do show it in a demo video for this bundle if you want to see it. But if we don't have such a simple case, like for example here, we clearly don't see a valid partition here. So we see some 100 megabyte or 900 megabyte partitions. These are clearly too small to have anything useful there. So we don't see what we need there. So for pretty much all kinds of recoveries, the first step you want to take is you want to start runtime image. So what this will do is this will maintain a sector map, first of all. So sector map is just a file which lets us know the sectors that have been retrieved in the past, so that RStudio knows which sectors have been good, which sectors have been bad, and it's going to use this sector map to make sure that it never reads the same sectors twice. So if you try to read the same sector twice for any reason, it's just going to take it from the image file that it's also going to maintain. So basically, whenever it reads any sector, it's going to first save it to the image file, then it's going to mark down its status in the sector map, and then it's going to move on. So you should always enable this as the first step. You should never be just double clicking on partitions without enabling this, because this will make it kind of lighter on the drive, and this will reduce the level of data loss. Like, we'll have some sort of partial recovery even if the drive dies, for example, part way through the recovery process. So always do this as the first step. Press OK. In this case, so what VMDK image file does is it doesn't store, it's sort of like a basic compression algorithm, so it doesn't store empty space. So if I have, for example, like a 1 terabyte drive, the image file will be much less than 1 terabyte. So it'll only take up space that's actually used by the drive. So this warning comes up because I don't have 1 terabyte of empty space, but potentially that might be okay if this drive has less than 1 terabyte of data, or if it's completely full, this will not be okay. I'm just going to press yes here. So the first thing that I would try to do is launch a scan on this drive. So primarily I'm doing it this way to figure out what the condition of the drive is, because assuming this drive just came for the recovery, I have no idea how bad it is, and how bad it is will of course affect what I do next. So it seems to be going pretty well. So if it's going really well like this, I would just scan a little bit at the beginning, and maybe like 10 gigabytes or something like that, and see if the partitions I'm looking for will show up or not. Okay, so I've run into some bad sectors now. So it's no longer easy to keep reading the drive, so I'm going to stop it. And I'm going to see, and here it looks like I found at least one good partition. So the rest of these, again, you can tell by the size, but only this one looks good. So I see that the size of this partition is much smaller than the size of the drive. So there might be other partitions on this drive that that we could potentially find. So what we do next is I would do a partition search. So what this does is this reads a small number of sectors, and it tries to find other partitions. So in this case, it was totally successful. So I can see that if I add up now these 3 partitions, it's pretty much the whole size of the drive. So all of the partitions have been found. So at this point, I would start double clicking on these partitions and loading these file trees. So the file tree loaded, it looks good. So this is where typically you would call the customer and ask them what they need, because of course, ideally, because this drive does have some bad sectors, we saw that when we did the short scan at the beginning. It's hard to say how many bad sectors there are. We just know that they exist. And so we understand that at some point, this drive might fail. And we have to be selective in these cases. Like, we shouldn't just try to recover everything, because then what might happen is that we might get files that the customer doesn't care about, and then the drive fails and we lose what they do care about. So it's very important at this point to sort of contact the customer and ask them what it is that they want. So there is a useful feature in our studio to help you do this. So I can export recovery list. So what this will do is this will make an HTML file basically containing this information, so showing what we were able to find. So here is the file that it created. So it's an HTML file, so it can be opened by any browser. So typically you would send your customer this file and then they would open it. And then, for example, they can browse through it, and they can tell you what they need. For example, you might select the pictures folder or something like that, and then they will go export marked files to recovery list. And then it's going to create this text file right here, which they then email back to you. And then we go to our studio and we go import recovery list. And automatically it checks whatever the customer has checked. So this is very handy. It really simplifies communication with the customer. So you don't have to be on the phone with them going through all these files. It's quite useful. So after they have selected everything that they want, then we would go save mark to runtime image. So you want to do this. You don't want to recover because, well, we do have another partition, right? So we would have to go through this process again through the other partition, and they would have to send us a separate recovery list. So the reason we don't want to go recover marked right away is because, so what this will do is, because we have runtime imaging going, so what it will do is first it will save those files to the runtime image, and then it will be saving them from the runtime image to our computer. And this second step, saving from the image to the computer, of course, is going to take time. And our source drive is just going to be basically turned on and idling during that time. And of course, it's going to be taking more damage. So we don't want to do this. So this is why we go just save mark to runtime image while we're working with the drive, while we don't have everything we need yet. And we keep adding using this button because this is going to be faster because it only has to do one step instead of 2 steps. And so our drive doesn't have to idle. So we press this button and we go okay. So generally we want to do skip files with bad sectors, especially because the customer selected a bunch of pictures. So pictures like JPEGs, they will usually fail to open even if one sector within them is bad. So there's no point to continue recovering that picture after we find a bad sector. So in the first pass, we want to check that box. Okay, so now we're done, and we can see everything was good. So there's no bad areas, nothing was skipped, and we're good. So these pictures are okay. For example, if the customer didn't know what they wanted, like some customers might just tell you, oh, I want all my pictures, but they have no idea where they are. And even if you send them the recovery list, they don't know their own folder structure. So this will happen quite a bit. This is where we would use the find option, and you can select, for example, all JPEGs using this option as well. And it will just go through everything and select them. And again, we can go save mark to runtime image. And what's useful with runtime image is that it's, as I said before, it's never going to read the same sectors twice. So for example, if the customer told us to recover some folder, like we just did, and then they also told us, okay, I also want any other picture I might have missed, and I'm doing this procedure twice, it's automatically going to skip over all of those pictures that we have previously imaged. So it's never going to do it twice. So this is perfectly fine to do it the way I just did it, using 2 steps. Nothing goes to waste, nothing gets done twice. So this is one of the reasons we do runtime imaging right at the beginning. It's a critical step. And of course, now we want to go through all of this with the other partition as well, going through all of the same steps. And only after we have all of the files that we're interested in both partitions, or all partitions that we're interested in, then we start saving them. Because at this point, our data is saved, our files are saved on the image file. So even if the drive dies, it doesn't really matter. We could even turn off the source drive at this point and just work with the image. So now it's just saving. My source drive is off, and we're just and we're just saving files from our image. So this is the best way. You should just turn off the source after you're done imaging everything that you want. So that's it for this case. Pretty simple case, drive with a few bad sectors. Now we'll do a more complicated case next. Now I'll try a more difficult case. So I've connected a drive to my USB stabilizer, and as usual, first I'm going to make sure that it's on hard drive and not an SSD, and then I'm going to power it on. So just like last time, I'm going to check to make sure that the drive identified correctly, the capacity is correct, the model is correct. So in this case, I see two sets of identification parameters. So right away, this is a bad sign for me, because basically what the stabilizer does is it identifies the drive twice. So first it identifies the drive using USB disk ID, and this is how we get this stuff. So this is the USB identification parameters. And then the drive, and then the stabilizer sends the ATA over USB disk ID command, and we get the proper model and serial number of the actual drive behind the USB to SATA adapter. Because these came separately, this means that the drive was slow to reply to disk ID command. So usually, like if the drive is not bad, these would the two disk IDs would happen so quickly next to one another that you would just have one set of disk ID parameters in the log, like we had in the last case. But in this case, there are two sets. So right away, I know that this drive is substantially more degraded than the last drive. So that's a bad sign. So as usual, I look at the partitions first, not seeing anything useful here. So just like last time, just like for every case, I'm going to turn on runtime imaging. Press OK. And I'm going to try to scan the beginning of the drive to see if I can find any partitions. So all sectors are good so far. However, the drive seems to be reading at only a few megabytes per second. So by itself, this is not really the end of the world. There are quite a few drives that will read this slowly throughout the whole drive, but have 0 bad sectors. So I'm going to keep reading and see if I find any actual bad sectors. And it looks like I just did. So I'm going to keep reading a little bit longer just to make sure it's not just a few bad sectors, and it's actually a patch of bad sectors, and it does look like there is a patch of them. So now I'm going to stop the scan, and of course there's no partitions yet. I've hardly scanned the drive. So what I'm going to do instead is I'm going to launch a partition search. So how does any tool find partitions? So of course there are differences depending on the file system, but generally most file systems will have the main block of file system metadata. So if it's an NTFS drive, then this is the MFT, and this block contains all of the important information that we need in order to recover files. So it contains all of the file and folder names. It contains the addresses of all the files, all of the structure of files and folders, everything we need. However, in order to find this block, so there are a series of pointers. So basically, sector A points to the location of sector B, then sector B points to the location of sector C, and then sector C points to the beginning of the actual file system metadata block. So what RStudio is doing right now is it's reading the part of the drive that is most likely to have these pointers. Because just the fact that partitions did not show up right away, right at the beginning when we turned on the drive, it means that this chain of pointers is not fully there, but maybe it's just broken at the beginning. So what we're doing right now is we're looking for all of the pointers that may still be there on the drive, and if our studio finds any of them, it will automatically follow along the chain of pointers and try to find the partitions that way. So the upside of doing this is that we have to read a much smaller part of the drive in comparison to doing a scan of the first 10 gigabytes, for example, as I did on the last case. The disadvantage is that these pointers may not be there because they're quite small, like one sector or a few sectors, and especially on a drive like this that has many bad sectors, they may just not be there because they're locked behind bad sectors or they're missing for another reason, and they just won't be there. So the disadvantage of doing that in comparison to scanning the first 10 gigabytes, for example, is that when you're scanning, it will find not just the pointers, but it will be able to find the actual file system metadata block. So for example, if all of the pointers are missing, but the file system is still there, scanning will still find it, and it will still show you the partition. So it's sort of, there's a trade-off. So this is why I usually begin with the scan, and then I see if I can easily scan the first 10 gigabytes. Because if it's easy, if the drive allows me to do it, then this is a better way. And if it's not easy, then I do the partition search to try to hope that some of these pointers will be there, and I can do like a more targeted, more precise recovery. However, at some point, I will have to give up and concede that the pointers are not there. Another thing that we can see right now is how our studio reads bad blocks. So right now we're retrying bad blocks sector by sector. So the drive fails a block read, and the drive will fail a block read even if just one sector within the block is bad. And then our studio retries these bad blocks sector by sector. So this is what we want to do when we're doing a partition search. Just because these pointers are so small, we don't want to skip the whole block, because we may just skip what we're looking for. So we have to do it this way right now. But if we're, for example, doing a scan, we shouldn't do it that way if the drive has a lot of bad sectors, because of course retrying bad blocks is very harsh on the drive. And if we've given up searching for the pointers and we're just searching for the main partition file system metadata at this point, which is typically gigabytes in size, it's not really a problem to skip whole blocks. I'm going to disable bad block read retries. So it's just right here in the bad sector tab. I'm going to put the retries count to 0. And now I'm going to start a scan to try to find the main file system block. So see right away we're not retrying the bad blocks, so it's going a bit better, well, a few times better. So at this point I would wait a little bit more just to see if maybe this is like a short bad patch that I will get through and get to green sectors after it. So it doesn't seem to be getting better. So there are a couple of things a couple of steps that I can take at this point. So one, I can try to jump forward a little bit. So I could stop the scan and I could instruct it to begin I don't know, 50,000 or 100,000 sectors later. So we can give that a try first. So for example, jump forward like 40 megabytes just to see what happens. I'm going in blind myself for this case. So this is just how I would approach it. I have no idea if this recovery is actually going to work or not. So realistically, at this point, I would want to know if the whole drive surface is pretty much this bad, because if the whole drive is this bad, there's nothing that can be done just with read and stability handling tools. So if the whole drive is this bad, then realistically the only way forward is to send the drive to somebody who has like a class 100 clean air workstation, because at least the heads and the platters will need to be cleaned, and possibly the heads will need to be swapped, but maybe it's just a bad area at the beginning of the drive. So what I'm going to do is I'm going to stop the scan, and I'm going to start multipass imaging. So what multipass imaging will do is it'll automatically skip forward pretty aggressively, and this will let me know if there are good sectors further on this drive. So what I could do at this point, I could just let it do the multipass image, but generally it's a bad idea to just do multipass like that, because of course the advantage of multipass is that, like it's doing right now, it will automatically try to skip around the bad area. However, in this case, because the bad area is at the beginning of the drive, I understand that this is probably the file system metadata, and you don't want to skip the file system metadata. Okay, I've reached some good sectors now. Okay, so yeah, it's what I thought. So the drive just has a lot of bad sectors within the file system metadata. Now, I could just let it go like this, but this drive is in pretty bad shape, and I understand that there's a significant possibility that it will die completely before it finishes that image. And then what's going to happen is I'm going to have a skipped patch of sectors that's right in my file system metadata. So what that means is that I'm not going to be able to load the partition. I'm not going to be able to see like a valid file tree, and I'll be stuck just with raw recovery. So I won't have like valid file names, and recovery will be very partial. So if I'm looking just for some pictures, that might be okay. It depends. If I'm looking for any bigger files, this is not going to be okay. So I see it is skipping forward quite a bit. So I would not do oh, now it's reading like 100 megabytes. Okay, so yeah, so there are parts of this drive that are just totally good and parts that are totally bad. So I would try to still load the file system. So realistically, this case will probably not be doable on USB Stabilizer Tech. Like, I'm probably gonna need USB Stabilizer Pro to achieve a recovery here, a good recovery. But like if I just had the Tech unit, probably raw recovery is going to be the only way. So I would just let this go, and kind of keep an eye on it, see how it's going, and then go from there. But I'm gonna give another try to try to scan at the beginning, so I can possibly see a partition. Okay, yeah, that's really bad news. So when it freezes like this, what it means is that the stabilizer sent a reset. Like for every bad block, we try to read the drive. If the drive freezes for 2 seconds, we send a reset. In this case, of course, it's been much longer than 2 seconds already. So I know that the reset was sent and then it didn't work. So basically the drive did not come ready after a reset. So this is kind of the worst case scenario, because now what the USB stabilizer is going to do, it's going to wait 60 seconds and then it's going to repower the drive and it's going to keep going. So at this point, I know for sure this is not This is not realistic, at least with the tech unit, and definitely abandon scanning. And I would actually just unplug the drive at this point with my hands, because I can't, with the tech unit, I can't really do anything. I'll show how much easier all of this will be with the Pro unit in a second. Okay, so I'm guessing that was about 60 seconds. So we have a bunch of kind of internal mechanisms for kind of aborting out of this situation, but yeah, all of this stuff only happens after 60 seconds on the tech unit. So it's if the drive is this bad, realistically, that's just not good enough. So I'm going to power off the drive, and I'm going to show you first of all how to activate the free demo of USB Stabilizer Pro, because everybody gets 1 month of USB Stabilizer Pro for free, as I said earlier in this video. So what you do is you go here and upgrade to Pro. So I get this message here. So I'm gonna open Firefox and I'm gonna go to this website. I'm gonna put in my serial number here, verification code. So because I haven't, I still have my free demo on this unit. Now I'm just gonna press the next button. Try to get through this annoying verification thing. And I don't need to provide my credit card information because I'm entitled to a free demo. So at this point, the demo is already activated. So I can just close this page. And I'm gonna close our studio. And I'm gonna restart our studio. I'm gonna have to restart it twice in this case. So the way it works is first our studio kind of polls the device to figure out what version it is, and then it contacts our license server, and then our license server upgrades the firmware of the device. So now basically our studio still thinks it's a tech unit, but the firmware has actually been upgraded to the Pro. So when I restart our studio the second time, it's going to realize that it's a Pro unit. And now I have USB Stabilizer Pro. So the first thing I'm going to do is I'm going to take control away from our studio. So basically the way our studio works is it directly controls the stabilizer device using the API file, application programming interface. So basically we built them a way to directly control our device so that it can do that without our control panel. So in this case, I do want to use our control panel. There's a couple of features there that would be really useful for a case like this. So in order to take control away from our studio, I'm going to open our studio directory. I'm going to close our studio first of all. And I'm going to rename a file called DSDEV.DLL. So this is the API file. So now I can launch the stabilizer control panel, and I can launch our studio. Okay, now it no longer sees the device because we took away the control, we took away the API. Now, if I did not rename that file and I just started using this control panel in addition to using like regular unmodified RStudio, everything will be a mess. Like it'll just be a nightmare because basically the two applications would be fighting for control over the same hardware device. And you're gonna have a lot of problems. So you have to take this step. So now I'm going to get my drive back. I'm going to turn it on. Okay, and I'm going to refresh. So here is my drive. Now it's no longer under the DeepSpar. Now it's just now it's as if the drive was connected directly to the computer. So we see all the reads that our studio made when looking for the partition. And I'm going to do the same thing. I'm going to start runtime image. I'll just start from the beginning by making a new file. And then I will scan just like before. So right away we see it's quite a bit faster because the read timeout that we can use with USB Stabilizer Pro is anything we want. So we use 300 milliseconds. So basically for each read, it's going to be, for each failed read, it's going to be faster by 1.7 seconds. So quite a bit faster right away. It's still reading most of the sectors. So at this point, I would still let it go a little bit more. So now I'm getting to much worse patches. So here I'm missing most of the sectors. So this is where the skip button really comes in handy. So if I hold down this button, what the stabilizer is going to do is it's going to skip over those sectors without even attempting to read them. So this is very handy. This is something that I use all the time when reading drives like this. So I can just kind of hold skip, go forward a little bit, and then see what happens. So I see I have like 3, 4, 5,000 good sectors generally between each bad block. And so at this point, what I want to do is I want to try playing with read timeout. So 300 is pretty low. And if the drive is slow to read, like it might successfully read those blocks if we give it more time to try to read them. I just want to see if this is the case or not. Okay, that was a good patch of good sectors. It's not really related to the timeout increase that I did. We're just getting further to the end of this horrible patch. But increasing read timeout did not seem to improve anything. So clearly, like, those are almost certainly just bad sectors, and there's no point allowing the drive to do more internal read retries. So I'm going to put it back to 300, and I'm going to skip a little bit more. Okay, so it looks like I'm out of the worst patch of it, but the drive is very slow. So I had to increase read timeout to 2300, and there are still occasional bad sectors, but large majority of this is being read. So yeah, so we can see how long, like, some of these sectors are taking 400 milliseconds to process, but okay, so it's not that slow, so I don't need to increase it that much, because basically like, these are the longest times. So some of these successful block reads are taking, 300-400 milliseconds. So what I can do is I can put this to about 700, and I can see that they're dark green on the sector map. So those are the slow sectors. So we're at about 3 gigabytes. So at this point, I probably want to stop the scan to see if we found anything useful, whether it's partitions or raw files. So overall, I see this number here failed, 5,353. So these are the number of failed read commands in this session. So this includes both the timed out blocks and all of the skipping that I've done earlier. So our studio uses 128 sector blocks. So this is overall, 5,300 times 128. So I guess that's about 700,000 sectors. So that's what we missed during this session, and we're on 6.3 million. So in other words, roughly 90% of the sectors we read successfully during this session, and we missed 10%. So we still got most of the sectors, even with very aggressive skipping. We still got most of it. So we're gonna see. We're gonna stop, and we're gonna see. Okay, so we found the partition. So now we're gonna cross all of our fingers and all of our toes, and we're gonna double click on it, and we're gonna hope that it opens. Okay, so good sign. So I'm doing this recovery blind myself. I have no idea if this is gonna work, but it looks good right now. Okay, looks like this worked out, or I hope so. Let's see if, as usual, we're gonna see if this whole partition is just garbage somehow, or if any of this stuff actually opens. So this picture failed to open, but I saw on the sector map that it's just because there was a bad sector, so it doesn't really mean anything, and I'm gonna try another one. Okay, so at least there are at least some things. So hopefully this kind of gave you some idea of how to approach this kind of case. So this case is almost certainly impossible to handle with the tech unit. It's too limited, it's too slow. I didn't see any kind of situations where the drive froze completely, as it did for us when we were using it on the tech unit. So this is actually, it's quite possible for this to be because the read timeout is lower. We could use a lower one on the Pro unit. So this will make the drive not just faster, but also more stable, because the more time you give the drive to do internal read retries, the higher the chance that it's gonna get stuck so badly that even a reset will not bring it back. So it's not just faster, but it's more stable as well. But if I did see a situation where the drive started freezing completely, I would set an algorithm to handle that situation. So usually if the drive freezes, repowering it is the only way to bring it back, which the tech unit will do after 60 seconds, which is way too long. So what I would do here, if no data is retrieved for example 5 seconds, then do a repower and hit apply. And what this will do is that if the drive does freeze, the stabilizer will automatically repower it. So on the tech unit, such a freezing drive, that'll be the end. You can't handle cases like that. And on the Stabilizer Pro, you would just set an algorithm. There are quite a lot of cases that the tech unit will not be able to do. These kit drives that are this degraded are relatively common. So the tech unit is very limited because it's free. It comes free with RStudio, so it's better than nothing, but it's much worse than the USB Stabilizer Pro. So it costs, with the price drop, we just dropped the price by $400. So with the price drop, the price of the upgrade from the Tech to the Pro is $500. So it used to be $900, now it's $500. So I guess that's about it for this recovery. So now I'll go over the USB Stabilizer Pro a little bit more. So one major difference is that this version of device will work with any software tool. So if we go to disk management, we have this drive right here. So this is our connected drive. It shows up in Windows as if it was connected directly. So any piece of software that works with drives will be able to work with it. So you can use anything you want. So PC3000, MRT, UFS Explorer, whatever you want. It will all work with USB Stabilizer Pro. So this drive, this is actually the ARM processor of the USB Stabilizer hardware, which is pretending to be the connected drive. And this drive right here, this is the actual drive. So this is the heavily filtered connection to the actual drive. We see Windows can't tell anything about it. It doesn't know the capacity or the model or anything. It's basically just our low-level driver, which reads this actual drive using our own methods through our hardware. And for example, if we reset the drive, we see it disappears and then reappears. So this is why we disabled the sound notifications at the beginning, because this would be very annoying if Windows made that noise every time this happened. So next, some features. So the user interface stuff is really obvious. So log events. So the only thing that's not obvious here is that if you want to see slow reads, like I just used on the previous case to set the appropriate read timeout, you have to check this box so that it logs slow reads. It's off by default because it's pretty annoying if it's logging all the successful reads. You get a lot of messages in the log. But if you want to set the read timeout properly, you do kind of have to see how long slow reads are taking, because of course you want to set the read timeout to be a bit longer than the slowest reads to get all the good reads possible, and only cut off the read if it's gonna fail, if it's not gonna work out anyway. File system mounting. So you should never check this. Just forget about it, uncheck it, never use it. So what this will do is that this will allow Windows to mount the file system of the connected drive. So basically it's gonna assign a drive letter, and it's gonna allow you to browse it using Windows Explorer. Of course, this will only work on drives that are largely healthy or almost completely healthy, because Windows will not mount drives with issues. So the only reason this exists is that some people, especially in the forensics world, they just refuse to work with anything but Windows Explorer. It's a completely wrong way in every conceivable way, but some people insist on using it like this. So we have to add this option, but you should never ever enable this. Like, this will just cause you problems. There's no benefit. There's only a bunch of drawbacks. You need some sort of proper software to do file system analysis, like RStudio or many others. Forget about this, uncheck it, never check it. Turn off drive if inactive. So this is the same setting as in USB stabilizer text. So it will turn off the drive due to 5 minutes of inactivity. So there is a way to change this time so you can make it longer than 5 minutes. I'll put it up on the screen. Generally, as I was saying before, you should just be mindful of the fact that the drive will do bad things to itself if it's idling, and just be quick about it. Next, report drive as read-only. So this is just a single bit that reports to Windows whether the drive should be treated as read-only. So like for 99% of purposes, this isn't going to make any difference. So the only things that so there are some applications where it might change some settings. Like for example, if you enable file system mounting and you check this box to report drive as read-only, then if you right click on a file, you will not be able to see the button to delete files, because Windows will believe that the drive is read-only, so it will not even give you the option to delete files. Some applications will also make those kind of minor changes based on this reporting. Generally, this doesn't really matter. You can check it, you can uncheck it. It doesn't really matter. Most applications will not treat it any differently. Report bad sectors to Windows. So what this will do is this will not report any errors to Windows. So for example, if we're reading a block and if the block read fails, whether it's because of read timeout or because the drive responded with an error, stabilizer will respond error to Windows. So you do want this in almost all cases, because you want your tool to recognize that the sector is bad. Because if you uncheck this, what we will do is we will report the read as if it was successful and just fill those sectors with zeros. So this is only necessary for some kind of very, very badly designed tools, especially in the forensics world. There are such tools which will just crash or refuse to work when they get reported errors. So with those tools, you have to uncheck this to kind of trick the tool into working. Again, leave this checked and don't worry about it. Like, this is very obscure feature. Allow SCSI pass-through. So with USB commands, you can read them using standard USB, or you can read them by SCSI pass-through. So most tools, like RStudio, UFS, Reclaim, whatever, they will use standard USB commands to read the drive, and this is the right approach. SCSI pass-through, it's basically worse in some situations. It's less stable, and really, like, Microsoft, they don't really expect you to be reading devices using SCSI pass-through anymore. 20 years ago, this wasn't the case, and like 20 years ago, pretty much all the forensics tools used SCSI pass-through. There were some benefits to it back then. It's no longer the case these days. The reason we have to allow it is mainly because firmware repair tools like PCA3000 or MRT, they have to do some of the vendor-specific functionality, like building head maps, repairing firmware issues, things like that. They have to be done by SCSI pass-through. So in order for those tools to work, we have to enable this. But generally, just keep it checked, and I guess very, very rarely is there any benefit to blocking it, because your typical tools like RStudio will not be using SCSI pass-through anyway, as they shouldn't. So next, storage device type. So just like with USB stabilizer tech, like this is very critical to get this right. So it'll automatically change the read timeout procedure to repower, but this is not the only thing it does. So there are basically like 7 tiers. There are almost like 7 layers of communication in Windows, and our driver sits on every layer and filters every layer, because of course any one of those layers can cause Windows to drop the drive or crash. So we have to filter everything on every layer. And there are a whole bunch of internal timeouts on each one of those layers. And this will affect what those internal timeouts are set at. So it's not just this setting. It does other things internally as well, because basically the main idea is that hard drives, spinning drives, they will pretty frequently have successful slow reads. So they will, they might take half a second or something like that, but then they will respond. So some of the internal timeouts are set to be higher if this is selected, because there is a higher chance that we just need to wait a little bit longer in some situations. Whereas for SSD or any flash device, they will still have slow reads, but it's very, very rare, many, many times more rare than with hard drives. So usually with flash storage devices, they will either read quickly or they will not read at all. So this is why the internal timeouts are shorter. And when you use a flash device, you should use a much shorter read timeout, like something in the region of 200 milliseconds or something like that. Even lower sometimes. So read timeout reset. So this is what the stabilizer hardware will do when the read timeout window is reached. So we send read command, we wait for this many milliseconds, and then we perform whatever this procedure is. So very rarely should you use anything other than hardware reset or repower. So hardware reset for hard drives, repower for flash. Software reset. So USB, there's like 30 or 40 different software resets on USB. Like all but 1 or 2 of them don't work at all when the drive is actually hitting a bad sector. So there's one reset that very rarely works. And basically what we do, if you select software reset, we're going to test if it's working or not. And if it's not working, it's automatically going to use hardware reset. So for something like, 95% of drives, or maybe even more, when you select this, realistically, it's going to use hardware reset, because software resets don't really work for USB. So it doesn't make sense to use them. So controller reset, very rarely should you use this, because basically what this is going to do is that it's going to instruct our driver to reset your whole USB controller whenever there are issues. So this was primarily added for people who have like very, very poor USB 3 controllers, because if your USB 3 controller is remotely decent, it's not just gonna freeze. So there are some low quality USB 3 controllers that will just freeze permanently. And for those ones, you have to use controller reset. That's the only way to make it work at all. But this just causes a lot of problems. This will be a lot less stable, And you should just have a proper USB 3 controller, as I discussed during the hardware requirements section of this video. So generally just forget about it, use hardware reset or repower. So occasionally, very occasionally, you might want to use like SSD and hardware reset, but something like 95% of SSDs do not process resets. They will just freeze forever. So you have to use repower, but there are exceptions. For hard drives, again, occasionally there will be drives that do not process reset, a few percent of drives, and you have to use repower. But this is incredibly hard on the drive, incredibly. So it's going to fail very, very quickly if you're going to have to do this on every failed read. So if you do find out you're having to do this, use a long read timeout, like 2000 milliseconds or maybe even longer, because you really only want to do this as a last resort, because it's very, very harsh on the mechanics of the drive. And just keep in mind, if you have a case like that, it's very, very likely going to die partway through the recovery. Bad block read retries, generally just keep this on allow. So this only exists if you're going to use some very poor software tools that don't give you the control over kind of bad block processing, like what I just showed in our studio not too long ago, where you can tell it not to retry bad blocks sector by sector. So some tools, particularly like most forensics tools, they will not give you that option. So they will insist on retrying every bad block sector by sector. And if the drive has too many bad sectors, that's not possible. So if you select don't retry blocks, then if we see that the tool is retrying bad blocks, then we will automatically respond to all of the single sector retries with errors without even trying to read the drive. So sort of forcing the tool not to retry bad blocks. And same thing with sectors. So this is only if individual sectors are being retried. It's not going to actually process those retries. So generally you should use proper software like RStudio or most other decent software tools. They will allow you to change this behavior. Next, response to write attempts. So there are three options. So allow write is obvious. It will allow Windows and applications to write to your drive. Almost never should you use this, and if you want to use this, then you should know why you're doing this. So error and ignore. So error is if Windows sends a write command, the stabilizer hardware will respond with an error and it will not process it. So generally this is better behavior, but sometimes some applications, like particularly Windows, if you insist on using file system mounting for some reason and you put this on error, Windows may refuse to mount the drive. Occasionally some applications that try to write to the drive will have problems with this. Sort of the advantage is that if you select ignore, so that it'll be more stable for applications where some writes are occasionally being sent to the drive, which are pretty unusual applications to begin with. But the downside of ignore is that, so what this does is it basically tells Windows that the write succeeded, but actually it's, of course, we're blocking it. The downside of doing this is that if Windows thinks that the write succeeded, it's going to keep the contents of the write in cache. So if you write something and you read it back shortly after, you're going to read the stuff that you wrote, because Windows, if it knows that it wrote something recently, it puts it into cache, and if you read it right back, it's still in cache. So it's going to be giving you the new stuff that you wrote to those sectors instead of actually reading the drive and giving you what's on the drive. So if you're, for example, doing forensic analysis and you're doing file system mounting, then you kind of have to set it to ignore, which means Windows is going to try to update your file system metadata. And then if you use your forensics tool to read this back, you might get the new stuff. So you might get wrong metadata. It's one of the reasons why you should never do this. It's insane how many police officers use this. Again, if you're doing everything kind of properly, your software is not going to send any write commands to the drive to begin with, because it shouldn't. No data recovery software should do this, and they don't generally. So usually this doesn't matter. So yeah, just make sure you don't put allow write, because even if you don't mount the file system, occasionally Windows will write things, particularly like the MBR. Windows may decide to overwrite it, and just don't set it to allow write. But the other two, it doesn't really matter. So speed optimization, so standard and aggressive. So like I was saying, USB stabilizer text. So this only improves speed of reading healthy and fast flash storage devices. The difference between standard and aggressive. So aggressive might be like a few % faster on some computers, but it'll eat up quite a few CPU cycles. So basically, this is actually an extremely complicated algorithm. So standard is like an approximation that's like 99% as good, or like 1% the resources. And aggressive is if you really want like 100% speed, but it's gonna calculate some timings more precisely, and it's gonna eat up your CPU cycles. It's like a couple of % difference, and on some computers it's like 0. So generally just leave this on standard. So read timeout, I already discussed. Commands. So log smart attributes. We can ask the drive what the smart attributes are, and we can output them to the log. There are some purposes, like in some jurisdictions people might want to log that. Generally not that important. Reset DCO. So DCO is DCO and HPA. They're basically two methods to hide data on SATA or IDE hard drives. So if the drive has an HPA, then stabilizer will automatically remove it and give you access to the whole drive. For DCO, it will say in the log that the drive has DCO hidden area. If you press this button, it'll unlock it. 99% of users will never see a drive with DCO. So ATA password unlock, again, will say if the SATA drive has an ATA password, then we will put a message out in the log, and then you press that button. What it will do is it will ask you for the password. So you do need the password to unlock the drive. We also support smartware. So smartware support happens automatically. Like if you connect a drive with a smartware password, then automatically it'll put out a window asking you to input the password. And you need the password to be able to read such drives. So more settings. Save logs. Yeah, you should save the logs. Why not? Save data of each write attempt to project files. So you could choose to save the contents of what Windows writes into your project folder. So this is primarily used by like forensics instructors. Like if you check this, and for example, if you enable file system mounting, then it's quite interesting. You could actually see all the metadata that Windows tried to change, and some people use this to teach their students because it's very educational. Kind of as you browse through the folder structure, you can see what Windows is actually writing, what it's trying to change. But it's mainly for educational purposes. But it's very interesting for education. So this was primarily added for all the forensics instructors that use this product to teach their students. Timestamp, yes, straightforward. Block non-standard SCSI pass-through. Long story short, if you're going to use tools like PC3000 or MRT, basically any firmware repair tools, you should uncheck this. So basically, this is a pretty complicated subject. So there are different ways of sending SCSI pass-through commands in Windows, and there are good ways and bad ways of doing this. So what that means is that in the bad ways, sometimes Windows will crash in some way. So what this will do is this will block kind of the bad methods of sending SCSI pass-through. I guess the number one practical purpose of this is that some utilities of SSD vendors, I don't want to name names because I don't want to get sued, and any utility released by the vendor of the SSD, a lot of them are very, very, very badly designed. And what they will do is they will start spamming every connected storage device with poorly made SCSI pass-through commands. And what they're doing is they're trying to identify the SSD that belongs to this vendor so that their utility can provide you with some sort of functionality. Like if you can check, I don't know, the firmware revision and allow you to update the firmware. And those tools, you should never just keep them running. They're horrible in all kinds of ways. Some of those tools can potentially, if they start spamming us with some vendor-specific commands, it might cause problems for the stabilizer. And this is kind of why we developed this, to block that from happening. Generally, like if you're using PC3000 or MRT, you do have to uncheck this because some of the procedures that those tools are using will use those non-standard methods, and we have to allow it through for those firmware repair procedures to work. So you have to uncheck this. Just if you're using those tools, make sure you don't use any SSD utilities. Just don't use them. Repower duration. So this is a very dangerous thing to play with. So what this is this is how long the stabilizer will keep power off when doing any kind of repower. So 2000 milliseconds means whenever it repowers the drive, it'll turn off power, wait 2 seconds, and then turn power back on. So kind of the advantage of playing with this is that you might speed it up, like particularly with flash storage devices. So 2000 milliseconds, it's pretty conservative. So basically what this is if you put this too low, then the drive may not properly repower. So it depends on the capacitance of the storage device. So if the capacitance is high and you put this repower duration too low, then all of the states of, like internal states of the storage device may not be cleared by the repower. For flash devices, if you set this too low, then a number of different things can happen. So one is the drive may not actually repower. So the stabilizer will try to repower it and the drive will not repower. So it'll keep hanging and then it'll just be stuck there. So of course you can set an algorithm like I just explained in the previous case. So if it doesn't repower, you can get it to do a repower again. But again, if the repower duration is too short, then no repower might work. And then your SSD will just be frozen forever. But that's not even the worst case. So I've seen, like, this is not common, but I've seen a few SSDs and USB sticks that will basically fail to load their translation tables. If this is too low, what that's going to do is the drive will repower, but it's not going to load translation tables, and it will revert to some sort of raw state where it's going to give you zeros to all sectors. So the device will repower, it'll come ready, your tool will keep reading it, but suddenly everything will be zeros. So it's not going to be permanent, like at least none of the cases I've seen, like this, it's not permanent, like it doesn't change anything, but the state of the translation tables in RAM will be messed up. It's a really bad situation because your image will basically be corrupt at that point after this happens, and your image gets spammed with zeros, and it's a horrible situation. Again, I've only seen this a few times, like, probably, I don't know, 1%. I'm not even sure it's 1% of cases will behave like that, but I have seen both USB sticks and SSDs behave like that when you start choosing something very low, like under 1000 milliseconds. More than 95% of users should never play with this ever. So this is for professionals who really understand what they're doing. But 1500 is quite safe, but potentially, like that's why we said 2000, like we want to be 100% sure. So the default is 2000, but 99.9% you'll be fine if you use 1.5 seconds, so 1500 milliseconds. But yeah, this is something you play with at your own risk. Like I said, the vast majority of people should never play with this. It's dangerous. Next, log. Kind of pretty straightforward. Whenever there's an update, the log, and your PC has internet connection, the log will tell you, and you just press the update button. So the update is kind of 2 steps. So first, this control panel will get updated, and then you'll have to right-click quit, and then start the control panel, and then press update again, so that the driver updates. And then you have to restart your computer, because there's basically 3 different versions of the code. So there is this control panel, there's the driver, and there's the firmware of the hardware device, and all 3 have to be updated, and it's a 2-step process. So yeah, update, quit, start again, update, restart. That's how you update. Sector map. So failed. So this is the number of failed read commands during the session. It is not the number of failed sectors. So for example, if like in the previous case, if the block read is 128 sectors and you have 5 failed reads, then 5 times 128 sectors are bad. This square bracket, so this is the size of the last block read. So this will tell you what blocks your tool is using to read the drive. So this is kind of, you can use the two together to guesstimate how many bad sectors, but of course ideally your tool should have its own sector map like RStudio, and it should properly track this. This is just an estimate. I do use this a lot, I find, but this is just to give you an idea kind of on how things are going. Data. This is the first part of the last sector that was read. So this is primarily useful if you want to see, like if you're doing a full image, like if you're stuck doing a full image because the scanning, like you couldn't find a partition, then you can use this to figure out if you're currently imaging empty space, and maybe you can skip past, like if you have a bad patch or something and you see that it's zeros anyway, then you might want to skip it. Something like that. Again, it's handy sometimes. These 3 buttons. So these are skip. I already went over. So while you're holding skip, the stabilizer will not process any read commands. So it'll immediately respond with an error without actually attempting to read the drive. So I've used this extensively in the last case. A reset will immediately send a hardware reset. Repower will immediately do a repower. I use these all the time. These are very useful little buttons. Because especially when you're dealing with a case that's not very simple, like if you have a drive that's, I don't know, for example, freezing up sometimes, meaning that the regular reset procedure, which is using a single reset or repower, depending on what you selected here, it's not working. So like some drives, they will need multiple resets. Some drives will need multiple repowers. And before you set an algorithm to do this automatically, you start playing with it manually by using these buttons, because you want to see what it actually takes to get the drive to come ready if it does freeze. So if it's frozen, you can press reset to see if it unfreezes, to see if resets help, or you can press repower to see if repowers help, or how many times you have to reset the repower before it works. But yeah, this is how you play with it at first to decide what algorithms you have to set. And of course, for some very bad drives, if their behavior is extremely inconsistent, you might be stuck sitting here and doing this manually and just sit here for it's horrible. But some cases, there is no automatic way because they just behave so randomly. And then you have to sit here and do this. It's horrible, those cases. But yeah, you will have those sometimes if you're doing data recovery a lot. And then that's the unfortunate reality. So algorithms, there are unlimited uses for these. So basically, as I was saying, like you want to try to guess the behavior of the drive and then automate it as much as possible. Automate the read and stability handling process through these settings. So there are, I guess, 3 most common uses for this. So one is if you're dealing with like a hard drive and it occasionally freezes forever when you're doing a reset, just like we saw previously in this video, then you want to set something like this to do an automatic repower. Another common use for this is if you see some sort of clear pattern, which actually will be pretty often, then like for example, you might see a drive that has blocks of 5 blocks of bad sectors in a row, and then some greens, and then again 5 blocks of bad sectors in a row, and then some greens, and the pattern is consistent. Then you might want to do an algorithm like if no data is retrieved for 2 consecutive reads, then skip 3 reads. So for this kind of, usually we do 2 because pretty much all drives will have like 1 occasional bad sector, and you rarely want to trigger skips based on that. Of course, there are cases where you do want to do that, unquestionably. But generally, if you're seeing like a pattern of 5, you would do something like this. And this way, it will only do 2 failed reads, and it'll automatically skip the next 3 blocks for you. Because if you've seen the pattern, you know that they're going to be bad anyway. There's no point even trying. And this would pretty dramatically speed up your imaging process. Again, this is only good for like if you're using RStudio, if you're doing that scan, because of course, if you're using like multipass imaging, RStudio will do that kind of thing. It'll skip around on its own. But yeah, just multipass imaging is the last resort, not the first resort. So yeah, you would want to use algorithms when doing the scan plus image at the same time. Third purpose, so there are some SSDs, like PCI Express SSDs particularly, that will consistently require you to repower them twice in a row. So this is quite common these days. So it seems like some PCI Express SSDs, when they hang up, they leave some sort of flags in their firmware that don't fully get reset upon the first repower, and the next time you repower the SSD, it's still frozen, but it clears those flags. And then when you repower it the second time, then it works. So there are like quite a few cases like that. You know, the PCI Express SSDs that are highly degraded, that does happen. So for those cases, again, first you want to play with this using sector map, using this repower to see that this is actually what's happening. This is how you know these buttons, doing it manually at first. And if you see that this happens, then you set if no data is retrieved for 1 consecutive reads, then do a repower. So what this will do, this is like a special algorithm that we built to do 2 repowers in a row. So it'll do a read, it'll fail, it'll do a repower based on this read timeout. And then if this is set to 1, then this will trigger as well. And then it will do another repower, and then it'll keep going. So this is pretty useful for some PCI Express SSDs. One more common use of this, yeah, you can't use speed optimization with these algorithms. It doesn't really matter, like this is only for healthy flash storage devices, so don't worry about it. So the last common use, there's unlimited uses for this, but the last common use is that you will find storage devices, both hard drives and solid state drives, that will enter into a so-called offline state where they will immediately respond to all read commands with errors. So what you will see is that in the sector map, you'll just see like a just constant red, pages, just red. And what's happening is that the storage device has decided to go offline, and it's not even trying to read anything. It's just responding with errors. And in that case, you need to use an algorithm to do something like, for example, 5 consecutive reads, and then you do a repower. So it starts doing this bad thing, and because repower is the only way, usually the only way to get the drive to exit this offline state, and then yeah, you have to use an algorithm like this to repower. I guess just like this one. But yeah, you both SSDs and hard drives can have this, like particularly PCI Express SSDs. So that this kind of control is required for them as well. On this drive might go offline for me. I'll see if I can show you what this looks like. It's a pretty common situation. Oh, there we go. So just like that, you will see exactly like this. So this is where you do something like this. And it will repower it. So here, the whole disk ID was corrupted. Like this drive is pretty bad. Yeah, when you see like corruption like this, like the whole disk ID got corrupted, quite rare. Like the drive has to be pretty bad. Like this is a pretty unusual case. But yeah, if you see a red like this, the drive has gone offline. It's not gonna do anything until you repower it. Occasionally resets work, but usually you have to repower. Now I'll very briefly cover the RapidSpar USB Add-on. So this is another limited variant of the USB stabilizer, which can be bought as an option with the RapidSpar device. So this is a $900 package, and we're actually also including RStudio Technician into it since 2022, so more than a year now. So it's essentially the same thing. So when used with RStudio, it works like USB stabilizer tech. The only difference is that this version of this device can also work with the RapidSpar Assistant software, which is what I'm showing now. So I'll just briefly show how this works. We can start diagnostics. So diagnostics with USB add-on, it doesn't really show much. So the only thing it can do is it can do like a media test. So meaning it will read random sectors across the whole drive, and it will show what percentage of them was readable. Just to give you an idea of drive condition before you start. So we start the project. For the target drive where the live image will be stored, we can either store it on the target drive, which is connected to the RapidSpar device, or we can store it on an image file on this computer. So as soon as I start the project, we load the partition table. And so this is the point where you would typically decide whether you're going to use RapidSpar Assistant or you should switch to RStudio. Because basically the advantage of using RapidSpar Assistant is that it's less limited in terms of read timeout. So if you put it on skip BADs, it'll use 1250 milliseconds, so 1.25 seconds, and USB stabilizer tech, which is what the unit will work as, when used with RStudio, is limited to 2000 milliseconds. So basically this RapidSpar Assistant will process bad sectors 0.75 seconds faster than USB stabilizer tech when used with RStudio. So basically, if you're able to load the partition table using RapidSpar Assistant and you can see the files you need, then you should just use RapidSpar Assistant because it's going to be better for you. On the other hand, if you're not able to see the partitions, or you're not able to load the partitions, or you've loaded the partitions but you don't see the files you're looking for, in all of those cases, you should be using RStudio, because RStudio is much better at logical reconstruction than RapidSpar Assistant. So RapidSpar Assistant is pretty basic in this respect. So there will be more situations where RStudio can find partitions and let you target files. Quite a lot more situations. So you should take advantage of that whenever it makes sense. So the partition has loaded. So this is where we would call the customer and figure out what they want, and then verify that their files exist. We can use the search function as usual to, for example, find all JPEGs. Okay. It'll automatically find and select all of them. So there we can just press recover. As usual, typically on the first pass, we want to skip files with bad sectors because JPEGs will usually fail to open, even if there's only one bad sector in them. So there's no point to continue imaging them after a bad sector is found. We press OK and we let it go. And so what it's doing right now is it's doing the recover operation, which is just adding those files to the image file, which in this case is stored on our computer. After we are finished with this, I'll just abort it for now. After this is done, we could turn off our source drive. It's going to show up this message right now, working in target only mode. So what this will do is after I press yes, it's only going to work with the image file. So you have to be sure that you finished recovering everything that you want to recover. And then we're going to press save. So basically, it's just going to save at that point all of the files from the image, and any sectors that are bad will be filled with zeros. So this way, basically, we don't have to keep the source drive turned on while we're just saving from the image. This is typically the best process to use. And we press OK. Then we're done. So that's typically how you would recover a drive with RapidSpar Assistant. And again, if partitions didn't show up or you don't find what you're looking for, then switch over to RStudio. And for everybody who bought their RapidSpar USB add-on before 2022, so like 2021 and earlier, you're able to buy just RStudio Technician from us for $450. So that's only for you guys. So 2021 or earlier, RapidSpar USB add-on. In this case, you did not get RStudio for free from us. You can buy it for $450. So that's all I wanted to show. Now I'll briefly cover Guardonix Standard. So this is the most basic version of the USB stabilizer device. As you can see, pretty much all of the functionality is grayed out. Even the sector map is not available. Nothing is available because this is essentially a regular write blocker with a few minor benefits. So this is intended to be used by law enforcement professionals who deal with 99% healthy drives, and maybe once a year they will have a drive with a few bad sectors that would normally stop their imaging process. So the only real benefit of this device in terms of rate instability handling is that if the drive does freeze for 60 seconds, then this device will repower it. So it will help with very minor issues, but if the drive has more than a few bad sectors, then you really need control over read timeout, and you need one of the other additions. This is not going to cut it. So this is really not suitable for data recovery service providers. This is essentially just a write blocker. So I'll just briefly show how it works. So when we turn on the drives, Windows is trying to mount the drive, and it's endlessly trying to write to it, just like it's doing right now. So in order to use a write blocker like this, you basically have to disable file system mounting in Windows to prevent Windows from even trying to mount the drive, so it doesn't get stuck in a loop like this, trying to mount. So we disable file system mounting by opening command line as administrator, then opening up disk part, then we type auto mount disable, auto mount scrub. So now when we turn on the drive, Windows is not going to try to assign a drive letter, and we will not have problems. And you have to do this whenever you use any regular write blocker like this device, because of course it doesn't have proper file system mounting as we do in all of the other editions. Now we're ready to image the drive, so we can open FTK or anything we want, and the drive will show up right here just like you would expect it to. So that's about it. It's a very, very basic device. There's nothing really to say about it. Just the number one thing is that please do not expect this to do drives with more than a few bad sectors. That's not what it's for. This is the cheapest write blocker in the world, and that's essentially what it is. It's just a write blocker. It's not a data recovery tool. So now I'll go over Guardonix Professional. So more than 95% of Guardonix users have Professional Edition. Very, very few people have Standard. Standard is just too limited to really do much. So Professional version, it's sort of like USB Stabilizer Pro with all of the professional data recovery features taken out. Because the main kind of user base of Guardonix are law enforcement professionals or various investigators who deal overwhelmingly with healthy drives, and they might get an unstable drive like once a year or something like that. So if you're dealing with this once a year, you don't really have an opportunity to learn how to really deal with those drives. So everything that's a little bit more complicated, like manual control over read timeout or any of those algorithms that we had in USB Stabilizer Pro, they're not in this product. So this is made to be very, very simple for people who deal with this very, very rarely. So this is in use by some very, very large governments are using this on a federal level. So every single on-site team will have one of these units in case they run into a degraded drive. It's very handy because they do happen. They do come up once in a while. The main differences between USB Stabilizer Pro, like the main features we have taken away to make Guardonix, is number one, as I said, control over read timeout. So this one just has short, medium, long, or off. Short is 1.25 seconds, medium is 4 seconds, long is 10 seconds, or off, which means we're not using read timeout at all. So short, 1.25 seconds, it's a bit long, but it's not that long. It's kind of a moderate. It's not bad for drives that are not terribly degraded. So typically the way this is used is if you think that you have a healthy drive, then you choose long, because pretty much if the drive doesn't come back after 10 seconds, if it doesn't successfully read the block after 10 seconds, then it's never going to succeed. The drive has frozen, so we have to reset it. If the drive has like a few bad sectors, this is fine, because of course the longer you wait, the higher the chance that you will get a good read. So if you only have a few bad sectors, then you want to wait a long time because you're not really at risk of killing the drive if it only has a few bad sectors. If it's more than a few, then you just put it to short. And also, same thing here. If the drive only has a few bad sectors, then you leave this on allow. And if it has more than a few, then you don't retry blocks. And I'm going to show this on a real case a little bit later. So next thing we took away is SCSI pass-through support. So basically what this means is that Guardonix cannot be used with professional firmware repair tools like PC3000 or MRT. It doesn't support SCSI pass-throughs, so it will not work with those types of tools. Next thing that's missing here is the entire algorithms tab. So you cannot make custom algorithms like if-then statements like you can in USB Stabilizer Pro. Here instead we have the keyword search. I'll show this on a real case a little bit later as well. We have file system mounting, so we're able to like mount the drive, so we can just browse through the folder structure if we want. I guess one important thing that everybody has to understand is that for file system mounting to work, we have to send this response to write attempts to ignore. So what this does is it tells Guardonix to respond to Windows as if the writes were successful, but not actually write anything to the source drive. The downside of doing this is that Windows may store these writes in cache. So if you're doing file system mounting and you're browsing through this stuff to take a look, then Windows might have updated file system metadata in cache, so that, for example, if you see something you like, and then you go and you open up your forensic analysis software and you start, parsing the drive to create some sort of logs, that information might now be wrong. The metadata might now be wrong because the updated metadata might still be in cache of Windows. So it's very kind of unpredictable. So this is why like file system mounting really should not be used in any kind of remotely professional work. Well, because of this problem. If you are going to use it just to take a look, just make sure you turn off the drive. That will make Windows clear the cache. So if you looked at it, you saw something you like, then we're going to turn it off. We're going to disable file system mounting, and then we're going to turn it on. And this way the cache should be cleared and you can start your analysis. So this is important. You should make sure to do this. Ideally, of course, don't use file system mounting at all, and do your quick checks in software that can parse the file system manually, like RStudio, UFS Explorer. There's many forensics tools that will let you do it. But yeah, that's a better way to do it. If you don't have tools, then yeah, you can just do this and just make sure you turn off the drive. One other, I guess, important difference between USB Stabilizer Pro and Guardonix is that Guardonix will not allow you to turn off write blocking. Like in USB Stabilizer, we have an extra setting here, allow write. This is gone. So with Guardonix, you can never write to the source drive no matter what you do. So you are protected from user error. And this is required for some jurisdictions. Like some jurisdictions cannot use a product as a write blocker, which allows them to turn off write blocking. It's just not allowed. So this is why this is like an absolute write blocker. So any point, if you have the source connected to Guardonix, you can never write to it no matter what you do under any circumstances. So in a way, this is safer for forensics work. So now I'm going to run through a case. I guess I'll run through the keyword search functionality. So keyword file is basically just a file where we put every word we want to search one after another, and then we load the keyword file. So most of these settings are pretty self-explanatory. So search within text is we identify text by the presence of common delimiters, and then the search only happens within those text files. So this is if you want to kind of avoid having kind of false positives, which might be present in, for example, encrypted data or something like that. This is kind of will make your search more concrete. Match whole word, matches the whole word. It's pretty straightforward. Case insensitive search, so that's searching every version of the word, so with every letter being either uppercase or lowercase. So this is kind of a more complete search, but of course this costs a lot more resources because it has to search a lot more variants. Encoding, so these are the two types of common text encoding methods. So we cover both of them, Unicode and ASCII. Another major thing we support is searching in MFT records. So if, for example, there's a file or folder name that matches the keywords that you selected, this will show up. Very handy. Yeah, the other ones log keywords and then save. Yeah, these are self-explanatory things. So now we've loaded the keyword. Now, for example, if we start imaging this drive, it's going to be searching to here. And as we're imaging, it is searching and it is outputting everything into the log. So of course this will only work for like text files or MFT records. So here we have this show here, MFT records. So this is the actual file name that's been found. So this is actually quite handy. People use this quite a bit. So this is if you're not sure whether what you're looking for might be on this drive, you can start imaging it and put in some keywords into the keyword file. This might let you know early on that what you're looking for is really there. So typically every law enforcement organization will have a number of keywords that they're highly interested in, and they will put them there, and they will just be searching everything for those keywords whenever they do any kind of work. And yeah, it's not common, but if they do get a hit, that's usually very, very kind of important information for them, and that affects what they do on the scene based on that detection. So next I'm going to recover a degraded drive using Guardonix. So now I've connected a degraded hard drive to Guardonix. So the first thing I do is select the storage device type. So this must be selected. This is extremely important because basically if I select it as hard disk drive, then it will reset the drive using hardware reset, which is the appropriate method to use for hard drives. And if I select SSD or flash device, then it will use a repower to reset the drive, which is appropriate for flash storage devices. If we set this wrong, like for example, if we have an SSD and we select hard drive, then probably the process will just freeze because flash storage devices do not respond to resets. So everything will just be broken. And same way, if we have a hard drive and we select SSD flash, then what's going to happen is it's going to work, but it's going to kill the drive very quickly because repowering the drive, it's very harsh on the drive. Like it causes extra degradation very quickly. So we don't want to do that. It's critical to select this properly. So I correctly select hard drive. File system mounting, this must be off whenever you're dealing with any unhealthy drive, because this will only work for a healthy drive. And if we try to mount a degraded drive to Windows, all kinds of bad things can happen. Usually the system will hang or something like that. You could even have a total system crash. So this is why it's critical not to try to mount the file system if the drive is degraded. So this is only okay to use for totally healthy drives. So at the beginning, I don't know the drive condition, so I'm gonna set it to long because this is something that I will change as imaging is ongoing. And here again, I will set to allow. So these two settings will allow me to get kind of the maximum number of sectors, but they will only work if the drive has a very small number of bad sectors. So now I will power it on. So the drive has identified here. All of this is stored in the project folder. So I have all of this information and everything that will come up in the log. So now I'm ready to start imaging it. And I'll use FTK, but of course you can use whatever you want to work with the drive. The drive just made a pretty bad noise. The drive clearly has a non-trivial number of bad sectors. So right away we want to put the read timeout to short. Let's see how it goes. Okay, so the drive stopped making a bad noise, but we see how slow it is. So what's happening right now is that FTK is retrying the bad block to try to get every good sector within the bad block. So if the drive has a very small number of bad sectors, this is fine, and this is what you want to do to get the maximum, to get the best read. But if the drive has a lot of bad sectors, then it will simply die before the imaging process is complete. So we don't have a luxury of doing this. So on the fly, we can force FTK to stop doing this by using this option. So the next block it reaches, so we can speed this up. So if I hold skip, it will skip the bad sectors without even trying them. So there you go. So now you see that we're not retrying each bad block. So basically the Guardonix tells FTK that all of the single sector retries failed immediately without even retrying the actual source drive. So it's the only way to read some drives with non-trivial issues. And of course, Guardonix correctly reports that these sectors failed to read, so the FTK log at the end of this imaging process will correctly show all of the bad sectors that failed to read during the session. So that's about all I wanted to show for this section of the video. So that's it for this video. Let me know what you think. If you like this content, and as usual, like the video, and if you want to see other training videos on other topics, then leave a comment below to let me know. I'm not sure I'm going to make other training videos or not. It really depends on the feedback I get. There's a lot that I could cover. Like I could make a whole separate video on our studio, going into it in more detail. I could make a video on RAID reassembly. I could make a video where I cover degraded solid state drives, how to image them. There's a lot that I could cover, but it depends on whether people actually watch this content or not. Because this video took me 20-30 hours to make, easily, if not more. So it's very, very time consuming, and of course I'm only going to make them if people actually watch them. So we'll see how it goes, and thank you for watching if you've stuck around this long.